Right, okay. So the first question we're looking at here is page 282, question 13. So the question asks to plot the points on the coordinate plane below and join A to B, B to C, C to D, and D to A to form a quadrilateral ABCD. So the first point I'm going to plot is A, which is 2 and 3. So you go to your x-axis, you go to 2, then you go up as far as 3, and you plot your point. Okay. And call the point A, 2 and 3. Then we're going to plot B, so that's 10 and 4. So you go to 10 on your x-axis, up as far as 4, and plot your point. That's B, 10 and 4. Then you go to 12 on your x-axis and up as far as 9 on your y, and plot the point C, which is 12 and 9. And finally, you go to 4 on your x-axis and up as far as 8 on your y, and plot your point D, which is 4 and 8. The question then asks you to plot the points and join the lines together. Giving you a shape that looks, that is a quadrilateral, 4 sides. It then says to verify that one pair of opposite sides of ABCD are equal in length. So you can pick any 2 sides you want. I'm going to pick DC and AB. So that's 4 and 8 and 12 and 9 for DC. And for AB, we've got 2 and 3 and 10 and 4. So I'm going to prove that the opposite sides are equal in length. So when you see length, you should be thinking the length or distance formula that is on page 18 of your log tables. Always write down the formula because you get marks for writing formulae. So square root of x2 minus x1 squared plus bracket y2 minus y1 squared. Then you call your first points x1, y1, x2, y2, and you sub them into the formula. So you have square root of x2, which is 12, minus x1, which is 4 squared, plus 9 minus 8 squared. Okay? You simplify what's in the brackets. So 12 minus 4 is 8 squared, plus 9 minus 8 is 1 squared. 8 squared is 64, 1 squared is 1, so that gives me an answer of the square root of 65. Now, when you put the square root of 65 into your calculator, it does not give you a whole number, so just leave it as the square root of 65. We're going to do the same now with AB, x1, y1, x2, y2. So you've got the square root of x2, which is 10, minus x1 squared, plus y2 minus y1 squared. 10 minus 2 gives you 8 squared, 4 minus 3 gives you 1, and you square that. 8 squared is 64, 1 squared is 1, the square root of 65. So verify that one pair of opposite sides are equal in length. So you've got the same answer. So you can say, therefore, the length of DC is equal to the length of AB. Okay, so the next part of this question says, by finding E and F, the midpoints of AC and BD respectively, verify that the diagonals of ABCD bisect each other. So you're looking for the midpoint of AC, okay, and then you're looking for the midpoint of BD. So we'll do AC first. Okay, so we know that A is 2 and 3, C is 12 and 9. Okay, so always write down your formula. So it says midpoint, so write down your midpoint formula. So that's x1 plus x2 over 2, y1 plus y2 over 2. And sub into your formula, your x1, y1, x2, y2. Okay, so x1 is 2 plus x2 is 12 all over 2, comma, y1 is 3 plus y2 is 9 all over 2. So then we can see 2 and 12 is 14 over 2, 3 and 9 is 12 over 2. So 14 over 2 is 7, 12 over 2 give me 6. So the midpoint of the line AC is 7 and 6. And if you go up to your diagram, you will see that that answer makes sense. Now, not drawn exactly accurately, but it's more or less accurate. Okay, so you need a ruler to make it exactly accurate. Okay, so then I want to find the midpoint of BD. So I'm going to write down B is 10 and 4. And D is 4 and 8. So again, call it x1, y1, x2, y2. Sub into your formula. So x1 is 10 plus x2 is 4 all over 2. And then your y1 is 4 plus y2 is 8 all over 2. So 10 plus 4 is 14 over 2. 4 and 8 is 12 over 2. So that gives me an answer of 7 and 6. So let's go up to our diagram here again and see, does that make sense? Yep. So the midpoint is 7 and 6. So the question asks, by finding the midpoints, verify the diagonals bisect each other. So since the diagonals of the midpoints of both diagonals are 7 and 6, we can say the diagonals bisect each other. So you need to write that in an exam situation. So you need to say, since the midpoints of both diagonals are 7 and 6, we can say the diagonals bisect each other. Okay. Now, the last part of the question says, can you conclude that ABCD is a parallelogram? And give a reason for your answer. Okay, so ABCD is a quadrilateral. It has 4 sides. We know the diagonals bisect each other, but we don't know that if the opposite sides and opposite angles are all equal. Okay, so we're going to say no, because we would have to prove that opposite sides and opposite angles are equal. Okay, now the next question I asked you to do was page 298. Okay. So the question here says, if line 1, line 2, and line 3 are parallel lines, find the measure of the angles. Note it. Okay. There are several ways you can find the angles. Okay. Probably the easiest way of starting, I'm not going to spend too much time in this question, but you can start and say that this angle here is 40 degrees. because this and this angle here are corresponding angles. They're both in the top left of the parallel lines. Okay, if you find that's 40, well, we know that these two angles here add up to make 180 because the interior angles, so the two angles in between parallel lines, add up to 180. So then we can say, 180 minus 40 degrees is 140 degrees. So this angle here is 140 degrees. Okay,